Yeah. So you're studying, started studying networking, right? So what exactly networking? I think you read it, right? Yeah, what is that? Okay. Only data? You didn't read next word? Packets. Okay. No. Yes. Mm-hmm. Okay. Yeah, let me tell you one thing. So the first 3, 4 classes will be like theoretical classes. Okay. So there you are going to learn every basic part of it. I mean, networking. Okay. After that, we'll start with the practical part. Yes. So initially, I know that you'll get bored. Okay. But I don't have any option. I have to cover this one. Yes. So this is theoretical part. You should know this one. Understood? And in CCNA, most of the things they are like theoretical only, because this is a basic, okay, foundational. Yes. So here, yeah, I'm not saying that you don't have any practical. Yes, you have. Okay. So with that also, you have to learn theoretical part. Understood? So the first is like what exactly the networking is. Okay. If you want the exact definition, here it is. Okay. It is what? It's a group of interconnected nodes, links, or computing devices that exchange the data and resource with each other through a media. Okay, here each and every word is really important. So what exactly the network is? Network means what? It's kind of a web backend. Okay, where we are going to connect the different computing devices. It may be any device. It may be your mobile, it may be your laptop, it may be your PC, it may be anything that exchanging the data. Okay, and which should be connected through some media. What do you mean by media? What do you mean by media? It's a kind of a channel through which it is sending the or transmitting the data, I can say. Transfer means what? Transmitting and receiving. Okay. So transmitting the data. What is media then? It may be wired media, it may be wireless media. Okay. So this is really important. So without media, can we transfer or transceive any kind of data? No. Okay. So not only data, okay, we'll share resources also. What do you mean by resources here? Resource. Information will also be, it's kind of a data only, right? See, भाई साहब अभी उठ गया है. Yes. What do you mean by resource? Yeah, softwares or servers, or even you can say best example, like I hope you have seen some printers or scanners will be there in your college labs. Okay, so each computer will not be having a separate printer there. Okay, you will be keeping a single printer at the corner. Okay, and the same printer will be shared with every PCs. So it is because of what? It is because of the network. Okay, so every devices will be connected in a single network or a same network, I can say. Okay, so that particular printer will be shared with all the PCs. Okay, so this is what the exact definition of networking. Yes. So what is networking? It is a group of interconnected nodes, links, or computing devices that exchange the data and resource with each other through a media. Okay. Now, what is the history of this one? I don't know the exact this one is a history, but this is what I found. Okay. So in the year 1969, the agency called ARPANET. Okay, what is this ARPANET? Advanced Research Projects Agency Networks. Okay. So it started using the networking to transfer data from UCLA. That is, these are the two universities. Okay, University of California, Los Angeles to the SRI, Stanford Research Institute. They started exchanging the data between these two universities initially. Okay, so from then the network got evolved. Okay, initially the data speed was really low. Okay, and even the transmission speed, okay, that was also low. Yes, so but when the network got evolved, now we can see, yes, what is the speed now? We are really reaching the high speed. Okay, so this is what the network is, which we use to get, I mean, which we use to transfer the data mainly. Okay, so and even in the initial days, the security was not that effective. But now you can see there the security for each and every device is really effective. Okay. So next is, yeah, these are some different use where we use the networking. First one is what? Communication. Obviously, majorly we use this network for the communication. And then accessing resources, just like data and information, printer and scanner, software, other hardware resources. And then we have centralized control and centralized data storage. What do you mean by centralized control? A server we have, and then, for example, controlling the APs. Okay, AP means what? Access points. Okay, and then the centralized data storage we can have. Okay, so these kind of things they'll be using the network. Okay, just to transfer the data or control all these devices. Yes, after that, transfer of files and resources. These are few what do you call use of this network. Okay. Yeah, next is like types of computer network. So based on the medium of what it is using. Okay, this is whatever the type I'm going to talk about. There are two types based on the medium. As I already said you, one is a wired media and second is a wireless media. Okay, based on that, they just classify it as a two. One is a wireless wired networking and second is a wireless networking. Yes. So what do you mean by wired networking? Where devices are connected through a wire like twisted pair cable, coaxial cable, or fiber optic cable to transfer the data from source to destination. Okay, so this is what the wired media where we are using a physical cable, okay, from source to destination, okay, just to transceive the data between the source device and the destination device. Okay, what do you mean by wireless? The same thing it is used for, but it is wireless. We don't have a physical media. Okay, we use this air, open space. Okay, where we are going to transmit the radio frequency or electromagnetic waves just to transmit the data from source to destination. These are the two types of what? Network. Okay, based on the medium what we are using. Okay. So wireless we can see here. Here the devices transfer the data wirelessly through radio waves or electromagnetic waves. For example, Wi-Fi, we can take Bluetooth or access point, etc. Okay. Next, the types of communication in computer network. I hope you heard about this. Unicast, multicast, and broadcast. So what do you mean by this three? What do you mean by unicast? Way of communication. One to one. Okay. One to one. Multicast. Multicast one to one to many. Okay. Many and broadcast. Multicast one to all. One to all. Okay. One to many. Not a security of broadcast. Can you give any example for this? One to one. Mm-hmm. Are you sure? Let a single time send data. It not PCs receive data and then we send data in single time. Unicast it and multicast. Unicast only send data, not receive. No. Multicast is like Wi-Fi router. Okay, take your WhatsApp. Just an example, take your WhatsApp. Okay. So what is unicast? If you are talking one-on-one, one-to-one, this is called as what? One-to-one communication, unicasting. Okay, multicasting means what? Very selected people will be there in the group. Very selected people. Okay, so one will be talking and other will be listening. And what do you mean by broadcasting? N number of what do you call participants will be there, and you will be talking with them at the same time. Understood? So this is what the three types of communication. One is a unicast, second one is a multicast, and the broadcast. Unicast means what? One-to-one communication. Multicast means what? One to group or multiple. Okay, and broadcast means one to all. Okay, you want the exact definition? You can see here. Unicast means what? It's a type of point-to-point communication where a message is sent from one sender to one receiver. Okay, and multicast means what? It's a type of communication where a message is sent from one sender to multiple or a group of receivers. Okay, and broadcast means what? It's a type of communication where a message is sent from one sender to all the receivers. Okay, so these are the three types of communication. Okay, after this, whatever he was talking about, they are like transmission modes. Okay, have you heard about these three? Majorly we have two. One is a simplex mode and second one is a duplex mode. In duplex we have two types, half duplex and a full duplex. What do you mean by simplex now? Don't read it there. Unidirectional, okay.
Only send the data, not receiving the data.
Exactly. And half duplex?
Half duplex sending and sending.
Only sending the
Only sending. It will not receive.
Then at the same time they not send or receive.
Okay.
They take time first they send data,
then receive. Okay. What about full duplex?
Same time
Same the data.
Any examples?
Like mobile. Like
like walkie-talkie. And keyboard and mouse are
Yeah.
Okay. Simplex. So it's a unidirectional mode of communication or transmission between a sender and a receiver, where only one can send the data as a sender and other should act as a receiver, and receiver cannot reply back to the sender. What happens here? It's only unidirectional communication. Okay. What is happening between us? It's a full duplex. Full duplex, right? Yes. What if I say I'll be talking, you should be very quiet?
Simplex.
This is simplex. I'm not seeking any answer from you. Okay, you should only receive. You should only listen. Okay, this is what called I'm being the sender and you all are being the receivers, and you can't reply back to me. This is called as what? Simplex mode. Okay, and for example, you can take their keyboard, mouse, radio, or TV channel. Okay, like if the TV channel is broadcasting, yes, we can't reply back to that TV channel. Yeah, this is not good. Yes, can we do that? No, right? And half duplex means what? Yeah, it is a bidirectional communication, but one at a time. Okay, if I'm talking until I complete, you should be very quiet. Okay, once I complete my talking part, okay, then you can reply me. This is called as what? Half duplex. Okay, the best example is what? Walkie-talkie. I hope you have seen. Okay, it will be with the security personnel or someone. Okay, and next is full duplex. So it's a bidirectional communication where the communication between the sender and receiver can occur simultaneously. Okay, where both sender and receiver will be transmitting the data at the same time, simultaneously. Okay, so the sender and receiver can both transmit and receive at the same time. Yes, the example is like telephone conversation. Understood? So these are the three transmission modes we have in the network. Okay, so other than this, we have one more that is called anycast that you are going to learn in a IPv 6. Okay, anycast means what? That is one to nearest. Okay, one sender will be there and it will be sending the same data to the nearest nodes. Okay, how we configure that based on that one. Okay, So next, I hope these are your favorite. I hope you studied these all right. The architecture, yes, or the topologies. Sorry, not topologies. The architecture of the network. Okay, how many of you heard? How many of these? You heard all of them? Sure. Okay. What do you mean by personal area network then?
Personal area is public. Connecting with mobile.
Mm-hmm.
Passports, passport.
Mm-hmm. Exactly. And local area network?
Example of school, campus, hospitality,
Mm-hmm.
office, lab.
Okay. I mean, these are the few types of a network depending on the coverage area. Coverage means what? Before we have seen the type based on the media what we are using. One is wired and second is a wireless. But now we are going to learn what are the types based on the coverage area. Okay. So some of them I have listed here. First one is a personal area network, PAN, local area network, LAN, metropolitan area network, MAN, wide area network, WAN, and the last one is a campus area network, CAN. Okay, in that first one, personal area network. This is a basic type of computer network and it is restricted to a single person. Okay, for example, you have created your own network inside your home. Okay, where you are going to connect your mobile, your tablet, your PC, your laptop, okay, your TV. Okay, so this is what a personal area network, which is really restricted to a single person, and the coverage area will be very less as compared to the other type of network. Okay, that is called as what? Personal area network, where it establishes a communication between the computer devices in a workspace. And the maximum range of the network will be up to 100 meter, not more than that. Okay, so the data transmission speed will be very high as compared to other, because here the connected devices will be more. So that's the reason bandwidth will not be, what do you call, divided more here. Yes, so this uses a Bluetooth or Zigbee technology, and the communication media may be wired or wireless. If it is wired, it may use twisted pair cable, OFC, or a coaxial. Okay, nobody is using coaxial now, so they can use TPC or OFC. Okay, and for example, you can see here, this is what the you can take your Wi-Fi device, okay, or access point. To that one, every devices are connected. Your PDAs like personal digital assistants, okay, smartphone, tablet, printer, laptop, everything like this. Okay. Next is a local area network. Okay, I hope you heard about this a lot, right? This is the most frequently used type of a network where it connects two or more computers through a common communication path in a limited area. Okay, as compared to PAN, this is bit, I mean, the distance coverage will be high here as compared to personal area network. Okay. So here it uses a Ethernet or Wi-Fi. These are the two technologies which is used in the LAN network just to transmit the data. And the maximum range of this LAN is up to 5 kilometers. Yes. And if you compare the data transmission speed, okay, it will be high with the higher types of a network like metropolitan area network, wide area network. Okay, and the maintenance is also easy and it is low cost. Okay, for example, you can see this kind of network in a home or a school or library or college or office. Okay, next is a metropolitan area network. What do you mean by metropolitan?
It is.
Metropolitan means what? It's a city. Yeah, so obviously that means, this means what? It is going to connected, it's going to be connecting the devices within the city or multiple cities, I can say. Okay, so obviously the distance coverage will be more as compared to local area network. Okay, so this is a larger than LAN but smaller than the wide area network. Okay, so this type of computer network that connects the computers over a geographical distance through a shared communication path over a city, town, or a metropolitan area. Okay, same thing I said. So what it does, it is going to cover the more geographical area as compared to the local area network. Okay, just it will try to connect the some city or town or even some metropolitan area network. Okay, so this network mainly use FTDI, that is fiber distributed or cable distributed, as a technology with a range from 5 kilometers to 50 kilometers. Okay, and the data transmission speed is average here as compared to LAN. Okay, so it is a difficult to maintain and it comes with a higher cost. Why? Because anyway it is going to cover the higher distance. So there you will need a long cables and all. Okay, so there the cost will be high. Yes, so you can find this kind of network in towns, cities, or single large city, large area within some multiple buildings, etc. Okay, next is a wide area network. What is this wide area network now? It's a group of LANs and MANs which connects a larger geographical area with a shared communication path. Okay, the range of WAN is above 50 kilometers, where it connect two states or even the countries. And it uses a lease line or dial-up technology. Here, the data transmission speed will be very low as compared to LAN and MAN. Okay, and the best example for this one is what? Internet. Yes. So what the WAN is? Wide area network. Obviously, it is going to connect some two states or countries. Okay. So what do you think? Like how two countries are connected? Through wired media or wireless media? How it is?
Wired.
Wired? See?
Both, sir.
Pratik, you said something?
Wired, sir.
Yeah. It is wired. Okay. From one country to another country, we'll be having optical fiber cables. Okay. They laid it through the sea cable. Okay. So obviously it is going to cover the area more than the metropolitan network, that is more than 50 kilometers. Okay, where it will allow us to connect two states or even the countries as well. Okay, but the data transmission speed is really low because the distance it is covering, it is also large as compared to the LAN or MAN. Okay. Next is campus network. It is same as LAN, I can say. Same as LAN. Okay, but this is connected within the campus, I can say, within the college campus or school campus or any company campus. Yeah. So CAN is bigger than LAN but smaller than MAN. So this type of a computer network that is usually used in places like a school or colleges. This network covers a limited geographical area. That is, it spreads across several buildings within the campus. And CAN mainly use the Ethernet technology and which is ranging from 1 kilometers to 5 kilometers, and the data speed is really high because which will be covering very limited area, less than the 5 kilometers. Okay, you can find this kind of network in a school, college, or a building somewhere like this. Okay, so these is what the campus area network. So these are some other well-known types of network. Have you heard about any one of it? Yes, you heard? Which one? Oh, all. You heard all? What do you remember WLAN then?
WAN network.
WAN network?
WLAN.
Don't know?
Wired, local area network.
That's.
Wireless.
I hope you can see that. Wireless
Wireless.
local area network. Whatever the local area network we have seen, that was wired one. This will be wireless. Okay. Next is SAN, storage area network, system area network, POLAN, EPN, VPN, VLAN. Have you heard about all this? No? Okay, do one thing. This is the task for you. Okay. For tomorrow's class is just collect some information about all these types. Okay, I may ask anyone tomorrow. Understood? Yes? Got it? Write it down. Done. There are a lot of left-handers, huh? Did you find it? Did you find it? I thought you were searching something. Okay, is that done? Okay, next we have transmission medias. Okay, as I already said you, there are two transmission media. Yes, what are those? Wired and wireless. Okay, so what exactly is the transmission media? It's a physical path between the transmitter and the receiver, where it acts as a channel between source to the receiver through which the data can be transmitted. It is what? It's kind of a channel, I can say. Okay, between the source and destination, through which we are going to send the data. Okay, not only send, we can receive also. Okay, so here we have majorly two types. One is a guided media and second is a unguided media. In guided media, okay, you can take three types. One is a twisted pair cable, coaxial cable, and the fiber optic cable. Okay, and unguided media, the total open space we can take. Okay, obviously we are going to send some frequency. Yes, so these are the two types of transmission media. In that first one, that is guided media. So this is also known as what? Wired media, which consists of wires through which it transfers the data from source to destination, where the signal is directed in a narrow path way using the physical link. I hope you have seen the cables, right? These will be like some narrow channels. Okay, so through which we are going to send the data. Yes. So here the actual physical path will be there. We don't know what happens in the wireless. We don't know how it is traveling, but it is reaching. Yes. But what happens in the wired one? Will be exactly having a path from this device to this device will be sending the data. Okay. And in that one, we have three types. Okay, first one is a twisted pair cable, second one is a coaxial cable, and the fiber optic cable. Wherein twisted pair cable and the coaxial cable, the data will be formed in the form of what? electrical signals. Okay, and the fiber optic is having
Like that.
a light signal. In these two, twisted pair cable and the coaxial cable, they may be of copper cable, okay, through which we are going to sending the data in the electrical signal. And I hope you have seen the fiber optic cable, right? Through which it will send the data in the light form. Okay. So in that first one, twisted pair cable. Yeah, twisted pair cable. Why it is called twisted, Bharati? Why this is called twisted? I hope you work on these cables daily, right? Yeah, why it is called twisted? For grip, no. Anybody? Mm, no. Have you seen the cable? Yeah, this is the cable, but this is after crimping. Okay, see here. I'll show you later. So TPC consists of two separately insulated conducting wires with, twisted with each other. And these pair are bundled together in a protective sheath, and these are widely used transmission media. Okay, if you see this image, okay, so you can find some of the colors on that. Okay, what kind of colors you can see? You'll be having a green, brown, orange, and blue. Okay, and with that, it's not only 4 wires. Okay, you'll be having 8 wires. Okay, but same colors will be twisted with each other. Okay, and inside that there will be a copper. Through that only we'll be sending the data. Okay, on that copper wire will be covering one more what do you call insulation material. Okay, so the same colored material you can see, that is called as what? Insulator, which will be protecting this internal conducting wire from the interference. Okay, and to protect all of them, you will be having a external sheet. Understood? So this is what the twisted pair cable, where you can find the conducting wires will be twisted with each other. Okay, on that wires will be having one more protection sheet, and to cover these all 8 wires will be having one more protecting sheet overall. Okay, and this is widely used transmission media. You can find this anywhere. Okay, more than OFC I can say, just for the short distance communication. Okay, so this is further divided into 2 types. One is a unshielded twisted pair cable, and second is a shielded twisted pair cable. Okay, so what is unshielded or UTP? This is again the same shielded twisted pair, twisted pair cable only, but it doesn't have an extra sheet what it is having in the shielded one. Okay, it's all because of the interference and the temperature. Okay, so let's see what exactly this is. UTP consists of 2 insulated copper wires twisted around one another. Okay, the same thing you can see here, twisted on one another. Okay, and this type of a cable has ability to block interference and does not depend on physical sheet or shield for this purpose. This internal whatever covering you can see there, okay, that green or brown or orange or blue, okay, that will not be depend on the outer covering, whatever the white you can see, for just to block the interference. It can do itself. Okay, just to protect the internal conducting wires. So it is used in a telephonic application. And then shielded twisted pair cable, in short we call it as a STP. Yes, so this type of a cable consists of a special jacket it may be of copper braid covering or a foil sheet just to block the external interference. This may be used in extremely cold climate, okay, where the temperature will be varying. Okay, in that condition, we use this shielded twisted pair cable. Okay, normally these are what? These are unshielded. These are UTP cables. They are not STP cables. Okay, where we can use this STP in such a condition where the climate is really cold, extremely cold. Okay, just to block the higher interferences. Okay, we use the extra sheet on this conducting material. Even though we have one more, I mean, the colored, whatever the coating you can say, okay, that will also help us to block the interference. But still, for this, what do you call, extremely cold climate, okay, so we are using extra foil on this conducting material. Understood? And to cover all of them, we'll be having one more outer coverage, protecting sheet, I can say. Okay. So here it is used in a fast data rate Ethernet and in voice or data channel of telephone lines. This type of cable is most frequently used in extremely cold climates where the additional layer of the outer covering makes it perfect for withstanding such temperature for shielding the interior components. Okay. So next cable, how many of you have seen this one? Coaxial cable, where you are seeing?
TV cable.
Nowadays, yeah, it is only used with the TV cables from antenna to set-top box. Okay, what about the black cable you can see? That is called as what? Coaxial cable. So before this TPC, we used to use this really more. Okay, twisted pair cable, we used to use this coaxial cable. But after the TPC, we stopped using this coaxial cable. Okay. So what is this coaxial cable? This is also a guided transmission media which contains an insulation layer that transmit the information in a baseband or broadband modes, and it has an outer plastic covering containing an insulation layer made up of PVC or Teflon. So they're talking about this one, the outer jacket, okay, which may be made up of PVC or Teflon just to protect the internal conducting material. Okay, we have two conducting material here. This is a centralized conducting material through which only we are going to send the electrical signal from source to destination. Okay, on top of that one, we'll be having one more dielectric material or insulator, I can say. It will be protecting the internal conducting material. Okay, and after that, we'll be having one more metallic shield, and on top of that, we'll be having a outer coverage just to protect the internal components what we have. Okay, so each having a separate insulated protection cover, and this type of a cable is most frequently used in a extremely cold climate, where the additional layer of the outer covering make it perfect for the withstanding such temperature for shielding the interior components. Okay, so this was about the coaxial cable. After that, we have optical fiber cable. So it uses the concept of total internal reflection. Have you heard about this? You must have heard about this if you completed your 10th class or PUC or something. You must have studied about this one in physics. Reflection, refraction. What do you mean by these? I mean, what is the difference between these two, reflection and refraction? What do you mean by refraction? Sorry? Okay.
So light absorbs less refraction.
Come again?
Some of the light gets absorbed, that's called refraction.
Okay.
When it's completely bounced back, it's
Reflection means what? It will be in the, I mean, after bouncing on any surface, okay, or hitting on any surface, it will be in the same media. Okay, it will not go through that. If it is go through that, okay, I mean changing its angle, that is called as what? Refraction. Okay, so let's suppose like we have this surface, and if the light is hitting on this surface and it is going through that by changing some angle, this is called as what? Refraction. Okay, if it is being in the same media, then this is called as what? Reflection. And the same thing we use in the fiber optic cable, because it should be sending the data in the form of what? Light signal. So if it goes in the other media, then the data will be lost. That's the reason we use a total internal reflection. Okay, that should be reflecting the same media, and that will be sending the data from source to destination. And that's the reason for the longer distance and for a higher transmission speed, we use the optical fiber cable. Why we use the optical fiber cable between the countries? Okay, just for what? It can transmit the data for the longer distance with a higher speed. Understood? So it uses the concept of what? Total internal reflection of a light through a core made up of glass or a plastic. Okay, so they're talking about this one, the fiber core, which may be made up of glass or plastic, which will reflect the light. Okay, the core is surrounded by a less dense glass or plastic covering called as a cladding. I mean, this is a protecting sheet that will be covering this internal glass material. Okay, so it is used for what? Transmission of the large volume of the data from source to destination. Okay, so in these two, we have two types. One is a single mode and multiple mode fiber. Okay, what do you mean by single mode? Where this is used for what? You can see here if you want. Okay, this is what the multiple mode fiber signal. Okay, can you see this one? Yes, where we are sending multiple rays, or I can say multiple data in the same channel. Okay, so this is used for what? What do you call? Sending some multiple data in the same channel. Okay, and what do you mean by single one? We'll be sending a single data stream, okay, in that particular single channel, I can say. Okay, these are the two types of it. Okay, in multi-mode, you are going to change the angle of reflection. Okay, while you're sending the multiple data in the same channel, obviously you have to change the angle of reflection. What will happen if you don't? If you don't change the what do you call angle of reflection for the multiple data through that channel, what will happen? Data will be lost, or something will happen to the data. Okay, so that's the reason we have to change the what do you call angle of reflection. Okay, and we don't have that in single mode fiber. Yes, so because we are sending only single what do you call data through that particular channel. Okay, next is unguided media. Okay, where we are going to send the data in a wireless form. Okay, this is also called as what? Wireless data transmission media. Here no physical path is required to transmit the data. Okay, it will be sent in a electromagnetic waves, electromagnetic or radio frequency waves. Okay, where we are going to use a total open space or air. Okay, So here we have three types in unguided media. One is a radio wave, second one is a microwave, and third one is a ultra. What happened? So radio wave, these are easy to generate and can penetrate to the building. The sending and receiving antennas need not to be aligned. So the frequency range of this is what 3 kilohertz to 1 gigahertz. This can be used in both AM and FM, and this can be used in cordless phones. Okay, that will be using the radio waves for the transmission. Okay, so you don't need to like memorize. I mean, have to remember all these things. Okay, but you should know what are the different media what we use in wireless. One is a radio waves, second one is a microwave, third one is a no. Cordless is used with a radio wave. Okay, third one is what this one, infrared wave. Okay, so what is this one, radio wave? So where have you seen this radio waves? Have you seen radio? Have you seen radio? So in that we'll be having two options. One is AM, FM. What do you mean AM, FM? No. Amplitude modulation and frequency modulation. Okay, so forget about that. Don't think much about that. So this radio wave, so you just open the antenna. Okay, do you think it should be aligned with the satellite? No need, right? You just open it or you just leave it. Okay, but it will be receiving the signal. Okay, it will be receiving the frequency. Okay, and that frequency you should tune between this two range, 3 kilohertz to 1 gigahertz. Okay, I hope you heard some range, whatever the radio channel we have, like mirchi, tomato, whatever the things they have, right? So they'll be giving you their frequency range. Okay, 93.2 or something is there, right? So why they will give you? On that only you can find their channel. Okay, you just need to tune that one. You don't need to be aligned with that particular channel. Okay, that's called as what? Radio wave. So again, it is categorized into terrestrial, what do you call, satellite. So next we have microwave. Here this is a line of sight transmission, that is sending and receiving antenna need to be properly aligned with each other. So distance covered by the signal is directly proportional to the height of the antenna. So frequency range 1 gigahertz to 300 gigahertz. Here these are majorly used for mobile phone communication and the television distribution. Okay, what is microwave? Where have I seen this one? Microwaves. Yeah, dish TV antenna. Okay, until you don't direct to that satellite, it will not be able to receive the signal. Okay, it should be aligned with that particular antenna. Sorry, satellite. Till and only after that only it will be receiving the data. Okay, this is called was as what? Line of sight transmission. Okay, where the transmitter and the receiver should be aligned with each other. Okay, and the frequency range is like 1 gigahertz, 300 gigahertz. Okay, where it is majorly used with the mobile phone communication and the television distribution. Last one is infrared. So IR waves are used for very short distance communication. Then, I mean, they cannot penetrate through the obstacles. So this prevents the interference between system. So frequency range is like 300 gigahertz or 400 terahertz. This is used in TV remotes, wireless mouse, keyboard, and printer, etc. Okay, I hope you have seen this with a TV remote, right? Okay, after 10 meter, if you go, okay, it will not send or receive the data. Okay, within the same range only it can send or receive the data. Yes. So these are the three types of wireless. So next we have to study the connector. Okay, what we use with the twisted pair cable. Okay, so what are the connectors, Bharti? RJ45, we used only RJ45. You never used RJ11. We never seen. You've seen? Telephone line, exactly. Telephone lines, whatever the connector you can see, that is called as what? RJ11. RJ45 means what? This. These are the RJ45 connectors, whatever the white, I don't know which color it is. White, right? Okay, transparent white. Yes, it is called as what? A connector. Without this, cable is nothing. Understood? First one is the RJ11. RJ stands for registered jack 11, where RJ11 connects typically, typically have only 6 position and 4 or 2 contacts. They are not internationally standardized, but they used to be very popular choice for both commercial and residential telephone application. Okay, still we use that one with the IP phones. Okay, or even landlines, whatever landlines I hope you have seen. Okay, just to connect from that, what do you call? What do you call this one? Yeah. Okay, you understood, right? Okay, to connect from that to the actual system. Okay, we used to connect this RJ11. Okay, and RJ45, registered jack 45. So this is a connector which is having normally 8 positions and 8 contacts. Okay, if you see here. Yeah, these are the two connectors. Okay, the first one is the RJ11, where you can see only 4 contacts. Whatever the gold color contacts you can see, connectors, this is of RJ11. Yes, and RJ45 is having 8 contacts, because how many wires we have in the twisted pair cable? 8 wires. So just to connect those, we have to have 8 contacts, so that the same thing will be on the RJ45. Okay, so this is majorly used in every network, in data center, in anywhere I can say. Okay, okay, as we're talking about the cables, okay, we'll finish this also, like network cabling and its standards. Yes, so here I think now only the one sir came here, right? He was talking about crossover or straight. Okay, I said crossover, straight. Okay, so these are the different types we have in cables. Okay, so why they exactly use for? So network cabling has 3 types, connecting different devices using twisted pair cable. Okay, they are like straight through cable, crossover cable, and the roll over or a console cable. Okay, so Bharti, what is this straight through cable? Do you remember the color code? What is that?
Orange, white of orange. White of blue.
Sure.
Green. White of green. Green. Blue. White of blue. Brown. Sorry. White of brown. Brown.
Straight through color cable, color coding.
ब्लू आएगा दोनों और एक ग्रीन ऑरेंज के साथ आएगा और एक ग्रीन ब्लू के बाद आएगा उसका ब्राउन.
Okay, we'll see it later. Okay, don't worry. Yeah, first one is a straight through cable. So these are primarily used for what? Connecting unlike devices. Unlike means what? Different type of devices, where all wires pair are in the same order on each end of the cable. I mean on both the end of cable. Both end means what? This end and this end. both ends will be having the same color code. Okay. Yeah, this one you can see. So which one is that?
Straight cable.
Straight cable, because both ends are having the same color code. Okay. So these are used for what? Primarily connect unlike devices. Okay, where all wire pairs are in the same order on both the end. Okay, and a straight through cable is typically used in a following situation. So what are those? First one, like connecting a router to hub, or connecting a computer to a switch, or connecting a LAN port to a switch or a hub or a computer. Okay, like different devices. If you want to connect, then you can go for the straight through cable. So next we are having a crossover cable. So what is this? Obviously it is used for what? Just to connect the same devices. Okay, so these are very similar to straight through cables, except they have pair of wires is crisscross. What are those? This allows for two devices to communicate at the same time. Unlike straight through cables, we use this crossover cable to connect the like devices. Just like what? Connecting computer to computer, router to router, switch to switch, hub to hub. Okay, so just to connect these kind of devices, we use the crossover cable. Okay, and one more we have this one. No, this is called console cable. Okay, so one end will be RJ45 and other one will be serial cable, RS232. Okay, so before we used to use this serial cable with all the laptops or computers, but nowadays we can't find any kind of serial connector. Okay, so that's the reason we have to connect this USB converter. Understood? So this is called as what? Console cable or Cisco cable, Yoast cable, rollover cable. You can call anything. Understood? So why this is used for? You can see here. A rollover cable, which is also known as what? Yoast cable, Cisco cable, console cable, that is used to connect a computer terminal to router's console port. Okay. So this is used for what? This is used by the administrator. Okay. So let's suppose like you bought this router for the first time. Okay. It is still not in the network, but we have to make it in the network, right? So we have to configure that one. Yes. You have to configure that one. So how you will do that one? Through the same console port. Okay. Which will allow you to get the access of that router CLI. Okay. And you can configure the particular device. Understood? It is just for what? Physical connection, taking the physical connection of that networking device. Okay, on the networking devices, you will find a console port. Okay, through that only you will be going to configure the device. Yes. So where one end of the cable is connected with the RS232 serial connector and other end is connected to the RJ45 connector, which is used by the administrator to change any kind of configuration required and to troubleshoot the issues. Okay, not only just initial configuration, if it is not there in network, okay, and to troubleshoot that also, you can connect this, what you call console cable from your laptop to the router. Understood? So these are the three types of cable we have in network cabling. Okay, after that we have standard.
Arun, just one,
Yeah.
just one question on that page.
Yeah.
If you could go back to that page, computer to switch and computer to router. I think computer to router, you said it's like devices, right? The second one, crossover cable. It is saying like devices. But when it says computer to router, it is like devices, but computer to switch, it is saying unlike devices. Can you just explain on that?
So both are L3 devices, right?
Correct.
Layer 3 devices. Okay. In that
Oh.
case, we can connect crossover cable.
Okay.
Okay.
Okay, I got it. Thank
Yeah.
you.
Yeah. Color coding standard for network cabling. Yes. So we have two types of cable standards. Okay. I mean, being a network engineer, you should remember this one because crimping is initial part of a network engineer. Yes, even though you don't know how to do it, but you should, I mean, you have to know it, obviously. Okay. So if you have time, okay, you just watch the YouTube and all, okay, you have to know what exactly the crimping is. What exactly crimping is, Bharti? What do you mean by crimping? Connecting this RJ45 connector to this LAN cable. Sorry, yeah, you can say LAN cable or Ethernet cable. Okay, this process is called as what? Crimping, with the help of these two standards. Okay, we use these two color coding table. Yes. So there are two types of a color coding standards, namely T568A, T568B. So these are two color codings used for what? Wiring 8-position RJ45 modular plugs. Yes. So the only difference between T568A and T568B is that orange and green pairs are interchanged. This is the only change you can see here. Okay. If you see this color coding and this color coding table, so wherever there is a orange and green, they are crisscrossed. White, green, white, orange, green, orange, white, orange, green, white, green. Blue, blue is same. Okay. White, blue, orange, green, white, brown, brown, brown. Where exactly the change you can see? Only in the orange and green pair. Okay. And we use majorly this one, 568B. White, orange, white, green, blue, white, brown. Sorry, white, blue, green, white, brown. Okay. So these are the 8 colors. Okay. What we use on the TPCs. Okay. What I said? What are the colors? Yeah. T568A color code, white, green, white, orange, blue, orange, white, brown. Okay. So when we use these two cables, when we use these two standards, when we connect the two different devices means what? Which color? Sorry, which cable? Straight through. Okay. So we use straight through cables. Okay. So the color coding at both the ends should be same. Either T568A, T568A at the both end, or else you can go for T568B, T568B at the both ends. Okay, which will make you a straight through cable. And if you're trying to connect what? Same devices, then you can go for the crossover, where one end will be T568A and other end will be T568B. Okay. So when we connect the same type of our devices together, then we use crisscross cable. So the color coding at both the ends of the cables will be T568B, T568B. Okay. So this is about the color coding standard. Clear? Nida? Great. Okay. Network topologies. Studied? Topologies? Studied? No. Okay. So what exactly the topology is? It's a physical arrangement through which various endpoints and a link in a network to communicate with each other. Okay, what we are going to do here? It's kind of a physical arrangement. Okay, where we are going to make the different devices to connect in the network to communicate with each other. Okay, so like that I have just listed some of the topology, the type of the topology. First one is a point-to-point, bus topology, ring, star, mesh, tree, and hybrid. Okay, so these are the different topology we have. Okay, so in that first one, point-to-point topology. What do you mean by point-to-point? Or exactly you will be having two devices. Okay, so it is a simple topology where the two nodes directly connected and reserves the entire bandwidth to communicate with each other. Okay, two PCs we are going to connect with each other. Okay, and the entire bandwidth will be between the devices. Okay, because anyway we are going to connect only two devices, and only these two are going to communicate with each other. Okay, this is called as what? One of the topology. And second is the bus topology. Okay, what is this bus topology? In this kind of a topology, all the nodes are connected or linked using a single cable with the terminator on both ends. And this arrangement uses a main cable acting as a backbone for the whole network arrangement. And all the nodes are connected in the backbone using the dropline cable. Okay, so if you see this image, you can understand. So this is the bus topology where you'll be having a backbone cable. Okay, where it is going to allow the different computers to communicate with each other. Okay, and if you don't connect this terminator, this is just a cable. Okay, so what the cable will do? What the cable will do? If it is getting any electrical signal, it will just pass through. Okay, so just to stop that one, you will be connecting terminators at both ends, just to know that this is what the topology is, from this to this end. Okay, and we'll be connecting the nodes in between. So how we connect? With the help of these tabs. It's kind of a T connectors, I can say. I hope you have seen this kind of connectors. Yes. So where, the same T tap, okay, where with the help of this drop line, we are going to connect these nodes. Yes. I mean, how the transmission or communication happens here? How it happens? Again, these PC devices, they are intelligent. Okay, they know what exactly the IP address is, what exactly the MAC address is. Okay, and I hope you know that the devices talk to each other only with the help of these two things, IP address and the MAC address. Okay, so when this node 1 wants to send any kind of a data towards the node 4, okay, what it will do? It will take that packet and obviously it is going to give the source IP, okay, destination IP, and then we have source MAC address and the destination MAC address. As a side, like this node 1 wants to talk with the node 4. Okay, let's suppose this is having a IP address as 10.1 and the MAC address as A. Okay, this is having 10.2, MAC address as B. This is having 10.3, MAC address as C, and this is having 10.4, MAC address as D. Okay, and when this node 1 wants to send the data towards the node 4, what it will do? It will give it this kind of information and it will send towards the main line or a backbone cable. What the backbone cable will do? Obviously, it will be sending the same data to everyone. I don't know who is node 4. I don't know who is 10.4. Okay, who is having the MAC address as D. Okay, but what it will do? It will send it through. It is a responsibility of those devices. the PC devices whether to receive it or not. Based on what? Based on this information. Destination MAC address or destination IP address. Whenever the data comes here, what the PC will do? It will check its own IP address and MAC address. Is it matching? No. So I'm going to drop it. It will come to node 3. What it does? It will do the same thing. Is it matching? No. So I'm going to drop it. When it comes to node 4, yes, it's for me. Okay, so I'm going to take the data. For reply also, it will do the same thing. It will just send it to the main line. Okay, and the main line will broadcast the same data to everyone. And that's what the responsibility of these node devices, whether to receive it or not. Understood? So everything is depends on what? The backbone cable. I mean, whenever this backbone cable get crashed, then the whole topology is a failure. Okay. Yeah, when a node wants to send a message over the network, it puts a message over the network and all available nodes in the network will receive the message whether it's been addressed or not. The same thing I said. Okay. What they will do? Whether it is addressed to that particular device or not, they have to receive it. Okay. So they will just again compare the thing. Okay. And they will take it or drop it. Yes. So the backbone cable is considered as a single lane of communication through which message is broadcasted. But how exactly it is going to, what do you call, send the data? Okay. So if the backbone crashed or fails, then the whole network topology get crashed. And bus topology uses the most common access method. Okay, that is CSMA, carrier sense multiple access, just to handle the data transmission in the bus topology. Okay, so there also it uses two methods. One is a collision detection and second is a collision avoidance. Okay, so what are these two now? First one is a collision detection. It is the access method used to detect the collision. Once the collision detected, and sender will stop the transmitting of the data. Okay, let's suppose like node 1 is sending the data, okay, towards node 4. So node 3, okay, at the same time node 2 is also sending the data. Yes, if it is not using the CSMA CA, if it is using CSMA CD, yes, what it will do? Obviously, the collision takes place in the backbone cable. Okay, so once the collision is detected here, these two devices, node 1 and node 2, they just immediately stop transmitting the data until this traffic clears here in the backbone cable. This is what? Collision detection. Okay, what is collision avoidance? Before sending the data, okay, the node devices, they will be sending a message towards a backbone cable. If it is available, then only I can able to send the data. Okay, if it is not available, then I'll be waiting. Okay, so let's suppose, like again, node 1 wants to send any kind of data towards the node 4. Okay, before sending the actual data, what it will do? It will send a signal between, towards this backbone cable. If the backbone cable is totally idle, then it will send the data. If it is not, then it will be on hold. Okay, it will be waiting until this cable is get idle. Okay, same thing you can see here. It is an access method used to avoid the collision by checking whether the transmission media is busy or not. Okay, if it is busy, then the sender waits until the media becomes idle. So this technique works effectively on, reducing the possibility of the collision. Okay, so this was about the bus topology. Next we have ring topology. So it is also kind of a bus topology only, but both ends are connected here. Okay, there you have seen the both open ends are were open. Okay, here what they'll do, they will just connect both of the ends, so that will become what? A ring topology. Okay. Sorry, I made it. Online, are you there or sleeping? Mr.
No,
Pradesh,
sir.
Yeah. Listening.
Gopal Krishna, is it your first class?
Yeah, sir. This is my first class today.
Okay. Off. Okay. Give turn. Okay, third one, ring topology. It forms a ring connecting a devices with exactly two neighboring devices in which each node is linked with neighbor to form a closed network. Okay. So this ring topology is also like, just like bus topology with both connected ends. Yes. I mean, the same thing will be, you can see here. Yes. So the different nodes, they are connected with the help of this drop line only. Okay. And the node that receives a message from previous node will be retransmit to the next node. What happens in the ring topology? If the node 5 is sending any kind of data, okay, and that will goes to this node 2, okay, and here the data will be flow in the form of clockwise direction. Okay, that will be decided by these terminators or repeaters. Yes, if it wants to do it in an anti-clockwise direction, that should be done on this terminators or the repeaters. Okay. So the most common access method of the ring topology is what? Token passing. What do you mean by token passing? What you've seen in this, what do you call bus topology? There, before sending the actual data, they used to check whether my backbone cable is free or not. So here also, what the node will do, just to check the availability of this particular backbone cable, they will pass a token. Okay. So how they will check that one? So if node 5 wants to talk with the node 4, okay, it will just send a token towards this backbone cable. Okay, what it will do? It will send it towards the node 2, okay, because they will flow the data in the clockwise direction. And again, node 2 will send it towards the next node, node 3, next node 4, and again come back to the node 5. So node 5 will get to know that the backbone cable is free. Then I can send the data. Okay, this is called as what? Token passing. So what is token passing? It's a method in which frames circulate from one node to another node. Okay. So next we have star topology. So here all nodes are connected to a central hub using a communication link. So each node need a separate wire to establish a point-to-point connection with the hub, which functions as a server to control the and manage the entire network. Okay. So here we'll be having a centralized controller. In a star topology, we'll be having a centralized controller where it is going to control all the nodes. And even the traffic will be going through the seam. Okay, I mean, this device 1 wants to send any kind of data towards the device 4. First, it has to take the permission from this centralized node. Okay, if this is going to allow, then only it can send the data from 1 to 4. Yes. So here it is kind of a one-to-one, point-to-point communication between the centralized controller and the all end devices. Okay. So in such configuration, if one node wants to transmit the data to another, it must send a request to the central hub, forwarding the message to the intended receiver. Okay, so here hubs or switches are mainly used as a connection devices in a physical star topology, and this is the most popular topology in the network implementation. Whatever the implementation you can see in any network, okay, this is mostly used. Okay, this was about the star topology. Next we have mesh topology. Is it kind of a mess? Don't you think it's messy? Yes. Here every nodes are connected with each other. Yes. So in mesh topology, each node is connected to every node, and it is usually reserved in, for critical network, as they extremely costly to implement and maintain. There are multiple paths from one computer to another computer, and it does not have switch or hub to control the whole network centrally. Okay, what happens here? This is just an example. The internet is a best example for what? This mesh topology, where each and every devices are connected through wired or wireless. Okay, in any way they can able to reach. Okay, if one path is what you call is not available, then I can take one more path to reach the destination device. Okay, this is called as what? Mesh topology, where one node is connected to all the nodes with multiple path. Okay, you can see here, if the node 1 wants to talk with the node 3, okay, it can go in any way. It can go directly, it can go through this node 2, okay, it can go through this node 4, it can go through this node 5, node 4, and node 3, like this. Okay, next is tree topology. So in tree topology, nodes are arranged in such a configuration that resembles a tree leaves, branches, and trunk. So how exactly the tree will be? Department?
One department, HR, finance,
पेड़ कैसा रहता है?
hybrid, hybrid,
पेड़ कैसा रहता है?
branches.
Will be having a stem. The
One router.
tree will be having a stem.
Multiple features can.
Okay, it will be having a trunk. Okay, to that trunk it will be having leaves. Okay, so this topology is resembling this tree. Okay, where this stem is nothing but what? This backbone cable. Okay, and these are called branches. Okay, to these branches we are going to connect the end devices. These are maybe my leaves. Okay, so that's the reason this topology is called as what? Tree topology. Okay, where you can find, or you can resemble tree leaves or branches or even the trunk, and the endpoints are connected to mid-level nodes that link to the tree trunk, where the trunk is backbone of the connection that links multiple mid-level nodes. Okay, can you tell me like what topology it is? Not this one. Yeah, this is what? Star topology. Okay, here only I think it is here only. Okay, so tree topology combines the characteristics of what? Both bus topology and the star topology. Okay, you can see the backbone cable, and to that backbone cable the star topology is connected. Okay, so tree topology is type of a structure in which all computers are connected with each other in a hierarchical fashion, and this is called as what? Parent-child hierarchy, because there is only one path exists between the two nodes to transmit the data. Okay, again, if the backbone cable fails, then the whole topology get fails. And the last one is a hybrid. Hybrid means what? Obviously we are going to use a multiple topologies. Okay, what is this topology? ring topology. What is this? Star topology. Okay, what is this? Bus topology. Okay, if you're combining this kind of what do you call topologies to create a single topology, that is called as what? Hybrid topology. Okay, understood? Shall we start the next? Yes? Still we have half an hour. Okay, let me ask. Yeah, online, any question here? Gopal Krishna, Mr. Pradesh, Pratik, Vaishnav.
I'm okay. Thank you.
Okay. Okay, if it is, then we'll end it here. Okay, because anyway, this is a new
Yes.
topic. Okay.
Sir, one doubt.
Yeah.
So how to access this recorded classes?
Don't worry, I'll be sharing the drive today. Okay.
Okay.
Just
Okay.
give me a detail on this number. Send me
Okay, sir.
detail. Okay. This is my number 9538 655 871.
Okay.
Okay. Send me your name.
Hmm.
Okay. And then
Okay.
your mobile number. And then your mail ID. Okay.
Okay.
And which course you enrolled.
Okay.
Okay. Send it immediately and I'll be sharing it tomorrow.
655, right? It is
Yeah, 9538 655
871.
871.
Okay, sir.
Yeah.